CloudDB, shaping your new normal.
Hello everyone, welcome to the 2021 APAC Groundbreakers Virtual Tour by APAC COUC. This year, our event would be the biggest one ever done, with 144 sessions, including the normal, workshops and hands-on labs. From 100 different speakers over 17 days. Also, it would cover sessions in 4 different languages as well. So please remember to register to as many sessions as you can. I would like to say thanks to all Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers, and our main sponsor, CloudDB. Now for today's session, we have using a PL/SQL table API to implement thick database principles by Peter Koletzke. Please feel free to write questions at any time during the session at the chat tab of the live webinar, and the speaker would be answering them at the end of this session. If there are any issues during the presentation, please feel free to contact me at any time on the chat tab of the live webinar. Now, without any more delays, I would like to leave to Peter with this amazing session. Over to Peter.
Okay. Thank you, Richard. You can hear me all right, yes?
Yeah.
All right, very good. So you got the title of the talk. The reason I did this session was mainly to explain a little more about the PL/SQL table API, but I have a couple of scenarios to start out with, which I wanted to see if you might be able to identify with. First scenario is your system has a legacy forms application that was built maybe back in Forms 3.0 or maybe even earlier, 2.3, and eventually it got PL/SQL in trigger code inside the application, but no PL/SQL was in the database because we didn't have PL/SQL in the 6.0 database back in Forms 3.0 days. So all the business rules code, all the validations were all in the forms. And it might be that it was migrated, through the years to current versions, 21.19c at the moment. But PL/SQL was still left in the application because it's too hard to move it. So little or no stored PL/SQL. Second scenario would be an application that's written in Java, and the Java developers also developed the database objects, designed the objects and created them. Business rules code is written in Java, and again, little or no stored PL/SQL because the Java folks know Java better than they know PL/SQL. Third scenario, similar, which is a JavaScript application instead of Java, and it could be that the JavaScript is on the client or server, but it's accessing database objects, and there's really no stored PL/SQL. The business rules code is written in JavaScript. So these work fine as a test in QA, sometimes even in user acceptance, and they work initially in production without a problem, but it could be that over time, performance lags because there's increased usage, there's some slowdown somewhere, because the logic accessing the database takes time, and excessive network messages also take time. So the application slows down, and it's something that you couldn't have predicted. Also, when you have these different languages, rewriting the application means you have to completely rewrite. If you have a new language that you want to go into, say you've got a forms application and you want to rewrite into JavaScript application, it's a complete rewrite, including all the business rules code, because that was all in the application. So the solution is the thick database and a table API. And I'm going to explain both of those terms if you're not familiar with those as we go. So we'll go through these 3 sections this afternoon. Basically talk about business rules briefly, just so we're on the same page with that. And then I'll introduce and and show a little bit more about the table API. And I've got some demos with sample code that you can look at, explain the principles. And then we'll just talk about some other other considerations that apply to table API. So we'll start with the business rules. Oh, and the sample code will be available afterwards. It's in this bit.ly link. If you just go out to the web now, you can get it. But it'll also be available in the session. And the presentation as well. There's a PDF of the slides there. So what is a business rule? This is my definition: a statement of a behavior, definition, or constraint that allows an organization to achieve its goals. So when you're doing analysis, it's really all about determining business rules. As analysis, you think of as kind of a waterfall life cycle type thing, but it's also used for things like agile development and other types of paradigms. Usually business requirements are equated with business rules. So this is how you communicate with the business users that you're achieving the goals that are needed for your application. So if you fully define business rules, then basically you're identifying everything that you need in the application, with maybe the exception of some details like the server specifics and development languages and software. Otherwise, it's all in business rules. So sample business rules: an employee is active in one and only one department at a time. So this is a rule that the business works on, and you would state that and check that particular statement with users. The employee's job end date must be on or after the job start date. Value of the country portion of an address must be from the list of world countries. Saving a change to an employee record archives an old version of the record in a history table. And that may not be the exact wording that you give to business users. It may be that they can just see, previous versions of a record. That may be a better way to put it for them. This is more an IT type thing. Only managers can view salaries other than their own for staff in their department. So these are all slightly different categories, and I do have some slides that explain a little bit more about some different categories, and also what you can do to generate and create business rule systems that store the business rule statement itself and test plans and things. And I'm going to skip these slides for the interest of time so I can show you some demos, but you'll be able to go to these slides in the slide deck later if you want to look at those. So for now, I'm just going to click over to the slides after that, if I can get the cursor working. So if you look at the diagram at the bottom, this is the way I think about business rules. You have a business requirement that helps identify the needs of the business for your application. And business rules can be written around that. It could be one or more business rules applied to a business requirement. And within the business rule, you can state a test plan for making sure that that business rule is fulfilled when you finish the application. And also, it may be that there's a link just using like a requirement ID or something like that back to the business requirement. That would be a technical way to do that. But test plans and business rules can be linked together that way. And they describe basically the business or the business requirement. So where do you put the business rules code? This is kind of the heart of this whole talk, because you've got different layers, even in the cloud, for different types of code. You can store code or write code in the database tier, middle tier, client tier, and in one or more or all three tiers. So how do you pick which one to go to? And this is where thick database comes in. Thick database is a term that's been kind of carried through from the days of thin client, when we were talking about thin client after the days of client server. Client server was a thick client, and then all of a sudden we had web applications that had not much code working on the client itself, so that was called thin client. And thick database was developed or invented or kind of promoted as a term that described putting all the code in the database, or as much as possible. So the objective is to maximize the power of the database to put your business rules, validations, and code as database constraints and trigger code as much as you can. And then for rules that you can't code as constraints, you call procedural code. So you would store database code in the database. And the reason for this is we don't have a create assertion in SQL yet. There's an article in this link here where Oracle people are describing, maybe 4 years ago, they were talking about how the SQL standard has the idea that there's an assertion, which means that you're validating your data before it goes into the application, or before it goes into the database. But we don't have that statement yet. So we have to write all this code. So in other words, you always validate data using database objects or code in this thick database paradigm. Constraints and triggers try as much as possible to enforce data integrity. Constraints, even like not null constraints, that they're part of the database definition, and they are considered database objects that enforce the integrity. And forcing access to be through a table API, which is a set of PL/SQL packages that I'll talk about, is one way to do this as well, because then that gives you the idea that you can have procedural code doing the validation. And here it's the same purpose, I think, as the assertion thing that I was just talking about. You're validating the data, and since the code is in the database, the application can change, and you can have multiple applications accessing the same database with the same tables, and they will all be going through this table API as a common enforcement of the business rules. So that's not to say that the user interface cannot have business rules code, but it's to say that you can repeat it in the client if it's something simple like number of children is a positive integer, birth date is on or before today. Simple things like that can be easily done in the client tier, in addition to having those enforced on the database side. So that's a brief overview of business rules. So about the table API. Table API is a PL/SQL API is application programmatic interface, or programming interface. So when we're talking about a table API, we're talking about a PL/SQL package for each table or business entity. Usually business entities and tables are similar, or sometimes one-on-one. And it means that all DML is accomplished through procedures. So you have an insert, update, delete procedure and a lock procedure. And if you're doing more than one row, you would have like an insert all, update all, delete all, lock all. You can't use the actual words insert, update, delete because those are reserved, but you can do something like I show here. And when I'm going to be showing the examples, they're all for single row scenarios. So you'll just see single row insert, update, delete, lock, because the multiple row insert, update, delete, lock have a little bit more code that you'd have to write, but the structure would be very similar to the package. So it's just for the sake of convenience, I guess, in explaining it, we'll look at the single row examples. So the procedures that you have for the insert, update, delete call business rule validation code before they actually call the SQL insert, update, delete statements. And the access to the tables is only through these procedures. So you do not do grants to any users. The table owner is the only is the only one that can get to the table data. The procedures can be written on different levels, and there's multiple strategies for how many schemas you need for this. And I'm going to explain that. I won't explain that too much, but you can use two schemas. So one owns the tables, one owns the packages. You can use 3 schemas, you can use 4 schemas, and that's explained a little bit more on the slide that I'm going to skip. But before we do that, I'm going to go to SQL Developer and show you some code samples for a PL SQL table API. And this will be for the jobs table. I'm going to zoom in a little bit so you can see the jobs table. It's basically 4 columns: job ID, job title, min salary, max salary. And the table API, I call it jobs TAPI, table API. The package spec is set up with a type, which is one parameter for each of the columns in the table. And then I create a table type for that, for the multi-row inserts, updates, and deletes. And then there's for the table type, there's a record type and a table type. And the insert procedure is overloaded, so you can either call it with the individual column values or with that record variable. So you would pass in a full record. Update is similar, single parameters for the columns and a row type. And delete is just deleting based on the ID. Lock is also locking based on the ID. And again, these are very simplistic. It's just for the sake of example. You would probably go a little fuller with a production version of this. So the package body, this is what we're doing for the insert, passing in the parameters for the column values, setting up a message variable, and then calling a procedure to check the data. So this procedure is basically the business rules check. And if that is satisfied, no error message will be sent back from it if everything checks. And then the insert will proceed based on the parameters. Otherwise, there's a raise application error with the message that came back from that check procedure. So insert, and the row type or the record variable insert just calls the individual parameter type insert. Update's similar, so I didn't add the check procedure, but you would have a check procedure before the update, and same thing for the multi-row or multi-record variable. And delete is just delete. Again, before you do the delete, there may be some business rules to check, so you would do a check statement there, and then lock is just a select for update. So that's kind of the way it looks. Then the business rule check procedure for insert looks like this. So there's the function in the package spec is just the parameters, again, individual columns, and then the row type overloaded. So here's where we would code the individual business rule checks in the body. So we're setting up a return variable, which is the message, error messages, if any. And I have a to-do here to externalize the messages because I'm hard coding the messages here, which is not a good idea. But it's not like, don't do what you see, do it the right way. And I've got numbers for each of these business rules. This is an ID number that would be, from my table, my business rule table. So the first one is to check that the min salary must be filled in if the max salary is filled in. And so it's checking for the nulls, and then it returns a message if max salary is not null and min salary is null. And then the next check is if max salary is less than min salary, which is wrong. So we get a different message there. And then the next one, so this is the first rule, number 15 or number 14. The next one is checking rule number 34, which means that you cannot insert a record with the job ID of PRES. So that is done by an administrator in a different way. So there's only one president, and that has to be done differently. So those are the check procedures, or the check business rule checks. And that's pretty much it. That's the row type version of that. Oh, and then I should show you what's happening here. the return variable, the return statement from this function, the check job insert, is concatenating a start character and end character around the error message. So the error messages are concatenated as you go through, and the concat message basically just adds a carriage return in between each one, and then this adds a start and end character, which I'm putting in a different package. So I'm defining my characters, the return character in the between statements, and then the start and end character are the curly brackets. And the reason for that is that I'm going to parse the messages apart later on, and we'll see how that works in the next demo. But let's go back to the slides briefly, and we'll go through some more detail. Oh, so that's the schemas thing, which I'm not going to go through right now. So the two calling methods for that I've used for the calling the table API, and they both use these data validation procedures that I showed. The first one, you're calling it directly from the client or the user interface, the table API procedures, and using the procedures, not direct SQL statements, not select, insert, update, delete statements, but calling the procedures, insert, update, delete, however you've written them. The second method is called from a view trigger, which means that you can issue a SQL statement, insert, update, delete to the view, and then the view trigger will call the table API, and then that will return back to the user interface if there's an error or not, or success. So variation would be to add table API procedures that call, view API procedures that call table API procedures, but the view trigger can easily call table API procedures if there's more than one table. So in all cases, you use the table API. So method one, you're calling procedure, you're using the ins, ups, and del procedures instead of SQL. And then you have to perform the commit from your client code in that case, because you have to see whether there was success from those procedures or not. There are some tools that are oriented towards SQL calls, like ADF, Application Development Framework. They're written for direct access to SQL statements, so you would use method 2 for those. But the benefit to this one is you can access any table and statement, because the procedure is not constrained by any kind of mutating table. So if you're using a trigger, it could be that you may not be able to do an update to some table because it would look like it's mutating. Oh, demo 2. Okay, so demo 2 is back to SQL Developer, and we're going to run a tester for, I'm going to zoom in because this may be kind of small. So I'm calling the insert procedure here in my table API and passing in values, but notice that the min salary is null, which violates rule number 14, and I should get an error message back from that. And the error message will basically raise application error, which will be handled in the exception. And obviously you can do this differently, but this is the way I chose to do it. And then at the bottom, you see the SQL DBMS output for a SQL error message. So we'll run that. I think I'm still connected. And DBMS output should show us. Yeah, so if you could look at the bottom here, you'll see the first thing with the asterisk is basically just a DBMS output in my procedure. And the next two lines are what returned from the procedure, the check procedure. And notice that it's got the curly brackets around the message, but it also has the ORA error number, which is not something that we would care to show to users. So a better way to do that, I've developed, of course, is calling my error package, and I've got something called distilled message. It's a function that strips out the curly brackets and it strips out the ORA error. So if you run it that way, you just get the error message. again, this is just a label that I filled in at the top here, so that would not appear in your production code, but the distilled message strips that out. So if we put all these together, I've got another tester here, and let's clear all this stuff out, which checks a number of different business rules. So I'm going to run that one again. This would be kind of a test suite, right? And the next procedure, or the next function call, is for rule number 25, which tests the min salary less than or equal to max salary. And in this case, min salary is greater, so I should get an error message from that. This is showing a scenario where you've got data that's got more than one problem. And then rule number 34 is the job ID is press, and we're not allowing that. That's not something that can be done with this user interface. And then this is both of the business rule errors together. So we have the press, and we've got the min salary and max salary problem. So if I can run all of these as a script and look at the bottom to see what the results are. So the first one is the same as what we looked at before. The next one is showing the error from the rule 25 problem. And then we're seeing the one with the job ID problem. And then the one at the bottom, I'll zoom in, is showing both statements because the data set had two different problems. It violated two different business rules. So it's showing the two statements with the carriage return in between. So that's what all of that code does. This is just an example of one way that you could use the table API. Back to the slides. So method 2 is using database views and view triggers instead of triggers on the views. So insert, update, delete, row level trigger calls the table API. The problem with this is that some validation code needs special handling because it might be cross row or cross table, and that might not be possible in the row level trigger. Or you have statement level trigger type things, which you don't have with views. So we'll look at that code. I've got samples of method 2 calls. And in this one, I'm going to be using the employee table. But I've created a view that's basically the employee columns with lookups to departments, jobs, locations, countries, regions, which are all related. They're equijoints here in the where clause. So it's a single row for each employee, but it shows also the information from all these other tables. So this is a view that normally you wouldn't be able to update to, but we've created a trigger. I've created a trigger. Sometimes I have a split personality. I guess it's we. So the trigger is instead of delete or insert or update on employees details VW for each row, there is no statement level, so you have to say for each row on views. And if inserting, then I call the insert statement. And again, this would run the check procedure. We'll look at that in a second. And then if it's updating, then we do the update procedure. And that's it. And if deleting, then we do the delete procedure. So the view trigger is fairly simple. And if there's an error message in the package, in employees package, it will return raise application error to the trigger, and the trigger will just pass it back to the caller. There's no exception handler here. So looking briefly at the package specification for employees, it's the same pattern as the jobs table, column for each, a parameter for each column. And I didn't put the record level overloaded procedures in here. Update, same thing. Now for updates, you would probably, in a production situation, want to pass in the old values as well as the new values to check and see if those had changed. The update procedures that I'm showing as examples here are updating everything. If you look at the update statement, here. So I'm not updating everything, even if it didn't change. And you may want to write some logic around that. So you're maybe creating a dynamic SQL thing that only updates the columns that need to be updated. So back to the insert, we have a check insert rules again for employees, and I actually commented that check out because I don't need to run it, but that would work into the insert statement or the insert procedure, just as it did with the jobs table. Check insert rules, and if there's a message coming back, that means there was an error, and if there's no message, then we can do the insert with those values. So again, this is working on the table, and the view trigger is calling that. So the scenario would be, this is a very simple view here, but it could be that this view needs to update more than one table. So the view trigger would call the table API for each table that it needs to update or insert or delete. It's not constrained to a single table. We should look at the employee package, I guess, briefly. Yeah, okay, so we did that. That's fine. The other thing that you can do, and this will be explained on a slide as well, but we can look at the code here, is if I have the example in the insert statement for the employees package. I've got this variable, a global variable that's a package specification variable. I set it up in the specification here, allow DML, and it's set to false so that if any application tries to call this package without setting this to true, it will fail because we have a trigger on the table. Insert, update, delete. If that is false, then we raise application error. You may not issue insert, update, or delete statements to the table. So that's in the, we override the setting of that gallow_DML variable when we do the insert and calling the procedure. So the procedure basically says we need to insert into the table, but the table has this protection on it that this variable has to be true. So it sets it to true, and it checks the data, does the insert, and then sets it back to false. And if there was an application error, it also has to set it to false. So any other subsequent call would go through that. So this is basically a protection on the table to be sure that nothing inserts, updates, or deletes without going through those procedures. Now, just having the grants set properly would do that as well, but this is just an additional check for that. All right, so this is the way the SQL flows in method 2. The insert, update, delete comes into the view. The instead of trigger intercepts it and sends the request to the table APIs. This is in the scenario where there's 3 tables, and then the table API actually would go through the table trigger to get to the table, and it may be that you don't have that table trigger, but this is where DML would stop if you had that trigger with the global variable that I just showed you. So this is the one that I'm describing here. I already talked about that, and this is just a code example of, well, it's just exactly what we looked at. So it's a lot of code to write, but you can generate a lot of this. At least the cookie cutter stuff, the things that are specific to the business rules, obviously you've got to write custom to the application and in the business, but all the stuff around it, to set up all the insert, update, delete procedures and all the variables and all of that, it's really, you don't want to type all that in. So generators are good things. The two that are here, the Oracle DD generator and Andre and Otmar's generator, are very full-featured. customizable generators that you have to spend a little bit of time learning, but they will do almost anything you need. You can also roll your own, and I say, roll your own, but it's probably easier to use a generator. And what you would do if you're rolling your own is you would do basically queries to the data dictionary like this, and you could generate little pieces of the code like the list of columns, or the list of columns in a parameter with a parameter p prefix, right? And maybe even more with the %type designations, so you can copy these out and paste it into your code, or you could just create shells around it that would basically generate whatever you need. But that's basically what these generators do. So there's really no need to do that unless there's something customized that these generators don't do. However, there's also SQL Developer Solution. So if you right-click on a table and select Table and Generate Table API, I'll just show you this instead of describing it. I'm pointing to it in the air, but you can't see what I'm pointing to. So let's say we wanted to do this for jobs. Right-click, Table, Generate Table API. And it was so fast that I didn't even see it. There it is. And of course, you want to do Control F7 to format it. But if we look at this, starting at the top, it looks kind of exactly like what I just showed. And the reason for that is because this is how I generated mine. And then I started making changes to it, right? So it's all here. And it gives you a really good head start for what you need to do. So that's a quick and easy thing to do. And then there's another one. Yeah, we just showed demo 5. There's another one, which is QuickSQL. And this is part of the Live SQL website from Oracle. It's an Apex application. So if we go, I'm going to go out there. QuickSQL, I think it's still there. And there's some samples. I'll load one. Session does expire after a while, so you got to be sure you're logged in. But it's usually pretty quick. So I'll load one of the samples that they've got. And what they have is kind of a short, and this is really small. They have some shortcut terminology that you can use. Basically, you just set up table names and column names, and you put in shorthand things like /NN for not null, and it'll create the table statements when you click generate. And one of the things you can do is add a /API after the table and generate. And then you'll see on the right that it generates a table API over here. And it's pretty much what we were looking at, but I kind of like the one from SQL Developer a little bit better. But if you get into this, there's a way if you go to settings and you like to do table APIs for everything, you can set PL SQL table API to yes, and then that you don't have to put in the /API. It'll always generate that table API. So that's another way to do it. So you just go to quicksql.oracle.com or Live SQL. You have to log in, use your Oracle login. And there's some YouTube videos out there about how to use it. It's an amazing application, actually. We did demo 6. Okay. Yeah, that's what it looks like. Okay. So some other considerations. This is basically just to say what the benefits of using database code for business rules. Faster performance is the main thing because the code is right next to the database data. It's in the database. Fewer messages, easy access. You don't have network trips going back and forth. It saves cloud costs because you're doing things faster, and you use your staff. I think a little bit better if you've got a division between the developers that are doing UI work and the developers that are doing database work. Database people can work on database side. user interface can work on user interface side, and they can work more productively. And I did mention this one where you're changing languages or changing technologies in the user interface. If a lot of the code is in the database, then you're rewriting less of it to get to your new language. Table refactoring, if you're adding a column or something, you just add to the table API and you don't have to worry about rewriting the whole thing because the table looks different. Refactoring. And this really applies, this diagram basically shows that it applies to any of these types of clients: Apex, Forms, ADF, MAF, JavaScript. They may go through different layers to get to the database, but once they get to the database, it looks the same. You've got a single way to get to a number of tables if you just use the database views or the APIs. Better performance. And this is kind of to prove that the performance is better. Tone Kopelars did benchmark tests, and he's got a YouTube video which is worth looking at. And I can't really describe all that he went through, but he was doing millions of rows of processing and comparing an application written in Java, plain Java without a framework, and an application written in PL/SQL, which was a row by row processing. I said not recommended because it was row by row, as opposed to set processing, which is recommended. So the results were that no PL/SQL, which is the Java, was 3 times, PL/SQL was 3 times as fast as no PL/SQL or Java. So it's faster, and the CPU usage dropped by half. So the thick DB or the PL/SQL was more scalable. It's because Java has a bunch of startup and shutdown statements that are needed for each call, and that adds a lot to the timing. And then he did it also with set processing. So he was passing sets of data instead of doing individual row by row things, and it was 62 times faster with PL/SQL. So it's a really interesting study that he did. So variation is to call a function to retrieve data. So you'd have a select function, and that means you don't really need a database view, but the virtual private database policies can filter data and to SQL instead of having the select statement. You rarely see this in table APIs. In fact, the generators generally don't produce it, but you can do it, and it might be something that's useful if you're using the procedure calls. Okay, and then I've got a couple slides that give some extra resources that you want to go to look at, I guess, blog entries and some more details about this thick database. So we're pretty much at the end here. So I'll give you the summary and then see if there's any questions in the chat. So first one is business rules are important. They should be defined and stored. And business rules can be linked to application requirements and test plans. And the idea with thick databases is that business rules code performs best when the code is in the database. It could be constraints or it could be actually PL/SQL code, or a combination usually. Table API is a good way to organize database code, and you can call the table API from the user interface code or from view triggers. And using a code generator, I would highly recommend that. Gets you going much faster. So thank you for attending. And let's see if there's any questions. I'm just seeing, can't be applied to, let me get a little closer.
Yeah. Can it be applied?
DDL. You can write procedures for DDL, obviously, and I don't think there's any reason why not. You have to do, normally user interfaces don't work with DDL. They normally work with data, but I don't think there's any reason why they couldn't. Okay, the next question was, I'm not seeing log tables that can have
Yeah, can I read it?
Yeah, please.
Could it be spiral effect? A table has TAPI that creates table DML logs that are kept in log tables that can have TAPI that create next level of DML logs and so on. Could it be spiral effect? A table that has TAPI that creates table DML logs.
Let me see if I can get that bigger.
Okay.
I mean, in general, I'm thinking that this is not outside of the realm. Let me see. Oh, here it is. Okay. Wow. All right. I've got to move this into view because I can't see it otherwise. Sorry. Okay. All right, let me go back. Yeah. Okay. Spiral effect. I see what you're saying. Okay. Yeah. Table. Sure. You can do. Yes, you can do all of this stuff. Table that has a table API that creates a table DML logs that are kept in log tables that can have a table API. So you could have, right, the log tables could have table API. Yeah, there's no reason not to. You do have to be careful of the transactions. You know, if you're stepping on one table that's updating and another table that's related to it with some relational key, then you could run into mutating table problems. But otherwise, yeah, all of that stuff can be done. It's a very powerful feature, and I think a lot of people are using it. Oracle has been using table APIs for many years. I remember back in the days of Oracle Designer and Designer 2000, way back then, the code that was generated from that tool was used table APIs. Okay, another question I think is coming in. I don't know. Here we go. Mutating problem could be avoided in compound trigger using statement section. Yeah, right. If you have a statement trigger, right? You don't. Yeah. Yeah. So it's just I just mentioned mutating tables because it's a thing that can happen, and you just have to. There's a solution for it, obviously, with the statement triggers, but.
Okay, so yeah, one more question. I think he's trying to update.
Oh, okay. DDL statements could be issued by IS personnel that are users as well.
IS personnel.
Yeah, so you'd want DDL. You can create DDL triggers, right, in the database that can kind of enforce business rules for your IS personnel, right? So you have to be careful of who has grants to do what, for one thing, but then if you're having problems with that, you can actually log DDL using DDL triggers. So that's one solution for that.
So Peter, maybe you can share your this one Twitter handler if possible, so that people can approach you.
Oh, sorry. Say that again.
Yeah, if possible, can you share your Twitter handle, Twitter account, so that people can reach out to you for any further clarifications.
I'll give you my email address instead. I'm not on Twitter very often.
Okay.
So you can do that. Yeah, because we should probably wrap up here, right?
Okay.
All right. Well, thank you.
Okay. Yeah, thanks a lot, Peter, and
All right.
thanks for presenting a great knowledge, that too at this your late night.
Yeah, right.
Right.
Okay,
Yeah.
take care. Thanks again,
And,
Richard. Thank you,
yeah,
everybody.
thank you, everyone, for your participation today, and please
Oh.
do not forget to register for another great session in the conference. So
Did you
please
want to try?
enjoy the rest of the conference. Yeah.
Did you
Peter.
want to share? I had these two files. I don't know if you need. How do you share these?
Have you shared in the folder?
Yeah, I shared the sample code. And then I've
Sample
got
code
this
on folder.
Yeah,
Table API code samples, right?
Yes, and then there's the slide deck in the slide decks folder.
Okay. Yeah, I think we have shared now.
Yeah.
People can download.
Okay. All right.
And
Very good.
one more where you have put slide decks. Huh?
Oh, slide decks. There's one in sample code and one in slide decks. Yeah.
Right.
I said share. Oh, there it is. Okay.
Yeah.
Okay, so these are not available afterwards, but you can get to me through the email account.
Yeah. So people
Yeah.
can.
Yeah.
Your email is visible, so people can take it up from there.
Okay. Very good.
Right.
All right.
Okay. So thanks,
Peter.
Peter. And
all right.
Thanks, everyone. Yeah.
All right. Take care.
Yeah.
Bye-bye.
Bye.
CloudDB, shaping your new normal.